Students, greeting of the day. For next 15 minutes, my concentration will totally be on numericals of solid state, and that is numericals based on solid state part 2. Numericals, they have been a criteria where the students, they have a phobia. So get rid of that phobia, because that will be important for you when we move for your competitive examination as well as for your CBSE examination. So be prepared with the numericals now.
So students, welcome back. Coming to this numerical based on solid state 2. So here we'll be dealing with some of the numericals which are left, which we have not taken in the first part. So coming to the first numerical, a compound formed by element A and B crystallizes in cubic structure where A atoms are at the corner of the cube while B atoms are at the face center. Give the formula of the compound. So here students, A atoms, they are at corner of the cube, means they are at 1/8 position. So for the calculation of number of atoms, we are taking 1/8 into 8, that is 1. And B atoms are at face center, means we know that face center is half contribution. So for the number of B atoms per unit cell, half into 6, that is 3. So A are 1 and B are 3, triple of it. So the formula comes as AB3. Is it clear? So what we have done, we have just taken up the position and multiplied the contribution of that atom at that position. Corner we know 1/8, so 1/8 into 8, and half as the face center, so half into 6, that is 3. Coming to the second numerical, a compound formed by element X and Y crystallizes in the cubic structure where Y atoms are at the corner of the cube and X atoms are at alternate phases. We have to calculate the formula of the compound. So number of X atoms as per the position, half into 2, that is 1, and Y atoms per unit cell will be 1/8 into 8 corner, so that is 1. So here ratio is 1:1, hence the formula of the compound will be XY. Very easy are the numerical, students, over here. Now this numericals, they are of 2 marks and nothing is to be done. 2 steps are to be written and you get the marks out of it. So be very careful in just understanding the concept. That is more than enough. The third numerical says a slightly not complicated, but just a calculation variation is there. That's it. Atoms of element B forms hexagonal close packing lattice, and those of element A occurs 2/3 of the tetrahedral void. What is the formula of the compound formed by these elements? So for that, when we are calculating the number of atoms for A for the unit cell, 2/3, 2/3 is given. So 2/3 into 2, that is 4/3, while the number of B atoms per unit cell are 1. So the formula will be A 4/3 and B 1. So that crisscross multiplication will be done. So A comes as 4 and B, which is divisible, goes as multiple. So B will be 3. So the formula will be A4 B3, which is the desired formula which we require. Coming to the fourth numerical, a cubic solid is made of 2 elements P and Q. Atoms of Q are at the corners of the cube and P at the body center. What is the formula of the compound and what are the coordination numbers of P and Q? So we know that it's a simple cubic geometry. So corner will be 1/8 into 8, that is equal to 1. In the body center, it is only one atom which is contributed, because the total atom goes into the center of the unit cell. So the formula of the compound is P and Q, because 1 and 1, 2, 2 1/8 into 8, that is 1, and body center is 1 into 1, that is 1. So 1 atom are there of P and Q. So the formula is P1 Q1, that is PQ. The structure of compound formed by P and Q resembles cesium chloride. So the coordination number of cesium chloride will be the coordination number of P and Q. So coordination number in cesium chloride is 8. Henceforth, the coordination number of P and Q will be 8 each. Coming to the fifth numerical, if the radius of octahedral void is small r and the radius of atom in close packing is capital R, then we have to derive the relation between small r and capital R. So that is something we have taken up into the text, but we are taking it over here. This octahedral void, then obviously uh, will be in portion to find out. So suppose the length of the each arm, because I have taken the portion with the diagram in the previous text. So here the diagram is not there. Suppose the length of the each arm of the square will be twice r, capital R, because r is the radius of atom. Let small r be the radius of the void. For right angle triangle ABC, which we have considered there in the diagram. So AC is equal to under root AB square plus BC square. So twice capital R square plus twice capital R square, that is equal to root 8 capital R. And we know that AC is equal to twice capital R plus twice small r. So when we substitute this value in place of AC, so twice small r plus twice capital R is equal to twice small r plus capital R. We have taken 2 as common. So root 8r is equal to 2 root 2 capital R. So that is equal to twice small r plus capital R, which we have calculated right now for AC. So small r is equal to twice capital R minus R. So small r is equal to root 2r minus 1 into r. So that is equal to 0.414 into r, which is the value which is required, that is 0.414. So small r upon capital R is equal to 0.414, which is the radius ratio of the octahedral void. Now coming to the sixth numerical, if NaCl is doped with 10 to the power minus 3 moles percent of strontium chloride SrCl2, what is the concentration of cation vacancies? Now for the solution, we know that doping of strontium chloride to NaCl brings in replacement of two Na ions, which are monovalent, by each strontium, that is divalent Sr plus 2 ion. But each strontium ion occupies only one lattice point. This produces one cation vacancy. Thus, doping of 10 to the power minus 3 moles of strontium chloride SrCl2 in 100 moles of NaCl will be NaCl with have vacancies to be 10 to the power minus 3 moles. So 1 mole of NaCl having cation vacancy after doping to be 10 to the power minus 3 upon 100. So that is 10 to the power minus 3 upon 10 to the power 2. When we take 10 to the power 2 from the denominator to numerator, it becomes 10 to the power minus 2. So 10 to the power minus 3 and 10 to the power minus 2 becomes 10 to the power minus 5 moles. Or the other way is there. The addition of strontium chloride SrCl2 to NaCl produces cation vacancies equal to the number of strontium ions. The number of moles of strontium ion added to 1 mole of NaCl is equal to 10 to the power minus 3 upon 100. So that is 10 to the power minus 5. As I said, 10 to the power minus 3 upon 10 to the power 2 it will be. So when you change the position from divisible to multiple, then it becomes 10 to the power minus 2. So it is 10 to the power minus 3 moles. Number of strontium ions added to 1 mole of NaCl is equal to 10 to the power minus 3 into 6.023 into 10 to the power 23. So that is 6.02 into 10 to the power 18 ions will be over here as per the desired answer. Now seventh numerical, in a close packing structure of oxides, 1:8 of the tetrahedral voids are occupied by bivalent cation, that is A, and half of the octahedral voids are occupied by trivalent cations, that is B. So we have to calculate the molecular formula of the oxide. So obviously when the positions are given, so for the bivalent cation A, 1 by 8 into 2, that is 1 by 4, and for the number of trivalent cation B, 1 by 2 into 1, that is half. So substituting the value in the formula, so A 1 by 4 and B is 1 by 4. Now 1 by 2. So we can, when we simplify it, A becomes 1, because if it's 1/4 and 1 by 2, you just form or bring them into the whole number. So when you bring them to whole number, it becomes AB2O4. So this is the desired formula of the compound. Coming to the eighth numerical, if of elements A, B, C are crystallized in a cubic solid lattice with A atoms at the corner, B atoms at cube center and C atoms at edge center. We have to give the formula of the compound. So for the solution, number of A atoms per unit cell, students, will be equal to 18 into 8, that is 1, and the number of B atoms will be 1 into 1, that is 1. C atoms unit per unit cell will be 1/4 into 12, that is 3. So the ratio is very clear, 1, 1 and 3. So the formula of the compound will be ABC3. Coming to the ninth numerical, in face-centered cubic structure of the compound, A atoms are present at corner, B atoms at face center. If one of the A atom is missing from lattice site, we have to give the formula of it. So for the solution of it, number of atoms per unit cell will be 18 into 7 because 1 is missing. So that is 7 by 8. And the number of atoms per unit cell will be, for B, to be half into 6, that is 3. Hence the formula of the compound will be A 7 by 8, B 3. So when we simplify it, it becomes A7, B 24, which is the desired answer. So students, these were the numericals. Just recapitulating, we have taken up all the numericals, around 20 numericals in both the section 1 and 2 we have considered. Just practice them properly and have a proper revision, because numericals, they require revision. Do the numerical a day, give the space, after 4 days again revise it by just seeing the question and try to solve the numerical. You'll be able to solve it, but if you are not, again go through the video and have a proper revision. Thanks a lot for listening and taking up into account this course. You tell your friends also and ask them to watch more and more of these videos, because I'll be coming up with all the chapters of CBSE in the days to come. So thanks a lot again for going through this video, and take care of your health, have a proper revision, and bye.